This video explains addition and subtraction of rational expressions. It's helpful to review similar and familiar concepts of fraction addition and multiplication. Recall that to add fractions with common denominators, we add the numerators and keep the common denominator. Similarly, fraction subtraction requires a common denominator. To subtract fractions with common denominators, we subtract the numerators and keep the common denominator. Let's review two simple examples. To add 2 over x and 13 over x, we add 2 plus 13 in the numerator and keep the common denominator of x. Thus we get 15 over x. Similarly, to subtract x over 3 and 8 over 3, we get x minus 8 over 3. Since x and 3 are unlike terms, we cannot combine them. Now let's consider examples of addition and subtraction with rational expressions. First, we consider examples with common denominators. To add fractions with common denominators, we need to add the numerators and keep the common denominator. Addition in the numerator requires that we collect like terms. We get 3x squared plus 4x minus 11 over the common denominator 2x plus 1. In general, we need to simplify our final expression. In this particular case, the numerator does not factor, so the fraction is as simplified as possible. Again, we want to add fractions with common denominators. We need only add the numerators. We get x minus 3 over x squared minus 9. This time, simplification is possible. We factor the denominator via the difference of squares formula, and we see a common factor of x minus 3 can be canceled. We explicitly write a factor of 1 in the numerator to remind us that when the factor x minus 3 is canceled, it doesn't just disappear. We have 1 over x plus 3. Notice that we should explicitly state any restriction that is no longer obvious after the cancellation. Therefore, x not equal to 3 is a restriction we need to state. That x cannot equal negative 3 is still obvious in the final expression. Let's consider one more problem, having common denominators. This time, we want to subtract two fractions with common denominators. We subtract the numerators and keep the common denominator. Notice, though, that the parentheses are required in the numerator to force the correct order of operations. Next, we distribute the subtraction and collect any like terms. Since we don't have any like terms to combine, we only need to consider whether simplification is possible. In this particular case, the numerator factors as x plus 3 times x minus 4, and we see that a factor of x minus 4 can be canceled. Cancellation leaves x plus 3 over 1, which can be written as x plus 3. In our final expression, it's no longer obvious that x cannot equal 4, so we make that restriction explicit. Now let's consider addition and subtraction of rational expressions with unlike denominators. We don't really need an entirely different process. We can just slightly revise what we already know. First, we'll need to get common denominators by multiplying each fraction by a clever version of 1. Then add or subtract as before. The least common denominator is the least common multiple of the denominators in the problem. And it will be important to use the least common denominator to avoid very difficult simplification at the end of the problem. Let's consider a few simple examples first. To add 7 over 8 and 5 over 12, we need common denominators. The least common multiple of 8 and 12 is 24. We rewrite 7/8 by multiplying by 3 over 3, and rewrite 5/12 by multiplying by 2 over 2. We get 21 over 24 plus 10 over 24. It's important to remember our goal of adding these fractions and avoid simplifying them at this point. After addition, we get 31 over 24, which is simplified. To compute 8 over 3x minus 5 over 6, we again need common denominators. The least common multiple of 3x and 6 is 6x. So we rewrite 8 over 3x by multiplying by 2 over 2, and rewrite 5/6 by multiplying by x over x. This gives 16 over 6x minus 5x over 6x. Since we now have common denominators, we subtract the numerators and get 16 minus 5x all over 6x, which is reduced to lowest terms. To subtract fractions with denominators 36x squared and 24x, we need their least common multiple. Finding this least common multiple, or LCM, is not always easy, but in this case we might notice that the LCM is 72x squared. We will review momentarily how to find the least common multiple of two expressions. But to get our common denominators, we multiply the first fraction by 2 over 2, and multiply the second fraction by 3x over 3x. This produces 10 over 72x squared minus 21 over 72x squared. Therefore, when we subtract the numerators, we get 10 minus 21x over the common denominator of 72x squared. We've already noted that the least common denominator is the least common multiple of the denominators, but so far we've relied on inspection to find this value. To find the least common denominator, first factor each denominator completely. Then the least common multiple is the product of the factors used, each raised to the highest power occurring on that factor. Let's find the least common multiple of 18x squared and 24x to the fifth. We factor 18x squared, and we factor 24x to the fifth. The least common multiple uses each factor 2, 3, and x to the highest occurring power. So the least common multiple is 2 to the third power times 3 to the second power times x to the fifth power. Thus, the least common multiple is 72x to the fifth. Now let's use this least common multiple in adding 1 over 18x squared plus 5 over 24x to the fifth. Our least common denominator we just found to be 72x to the fifth. So we multiply our first fraction by 4x cubed over 4x cubed, and multiply our second fraction by 3 over 3. Addition with the common denominators produces 4x cubed plus 15 over the common denominator 72x to the fifth. Let's consider one final example. Let's find the least common multiple of x squared minus 1 and x squared plus x. We factor each polynomial. X squared minus 1 factors into x minus 1x plus 1, and x squared plus x factors into the product of x times x plus 1. So the least common multiple uses each factor x, x minus 1, and x plus 1 to the first power. That's the highest power that occurs in any of the factorizations. Now let's add 2x over x squared minus 1 plus 1 over x squared plus x. We first need common denominators, and the least common denominator we just found to be the product x times x plus 1 times x minus 1. So we multiply our first fraction by x over x, and the second fraction by x minus 1 over x minus 1 to produce fractions with the correct denominator. Now we add our numerators to get 2x squared plus x minus 1 over the common denominator still in factored form. To see if any simplification is possible, we need to factor the numerator. Since 2x squared plus x minus 1 factors into 2x minus 1 times x plus 1, we see that a factor of x plus 1 can be canceled. Thus we get 2x minus 1 over the product of x and x minus 1 as our final simplified answer.